Hello, this is Nachiket Vatamwar recording for cmpe281. Please make a note of the 5 instances I'll be using. It is this one and their private IPs. Okay, and the security group which they are using is mongoDB. So the security group is as follows. This is the outbound traffic and this is the inbound traffic. So I'm gonna quickly log into, this is my jump box. I'm gonna log into my instance. This is the node 1 instance. Similarly, I'll log into other instances. Till then I'll pause the recording. So this is the mapping of the node name and the IP address. So let us quickly log inside Mongo. This is the primary. Let's do rs.status and check the status of a Mongo cluster. So right now node 5 is secondary, node 4 is secondary, node 3 is secondary, so is node 2 and so is node 1. So let us just create a database. Let's create a movies. Now we have created a database. Let's just add this data inside the primary database. Okay, as you can see, it is over here. Now we'll log inside go inside the secondary node. Okay, rs.save. Okay, use movies db.mm.find. Yeah, so as you can see, we have the data in the secondary. So we'll do the same thing for other 3 nodes as well. rs.slave. Okay, show dbs. Okay, use movies db.mm.find. Yeah, Heinemann with spark. So same thing goes for this one as well. Okay, so this data is over here. Similarly, the final one, rs.slave. Okay, let's use db.mm.find. Okay, so as you can see, we entered data in the first node, but it got replicated in all the other nodes. Now what we are going to do is we are going to quickly use IP. First I'll exit through all the Mongos. and I'll be back. So we are going to use IP tables to create a partition. So these are the rules which we'll be using for IP tables. I'm going to add these rules in node 4. What this is going to do is node 4 will stop listening to the traffic from node 1, 2 and 3. So will node 5. Now let us just go inside our Mongo. Okay, let's do rs.status quickly. Yeah, so as you can see, node 5 is not reachable or not healthy. Similar is node 4, but node 3, no, where is this? Okay, yeah, node 3 is secondary, so is node 2 secondary, and so is node 1, which is a primary basically. So since we're in primary, let us just add some more data. Use movies db.f. As you can see right now, we have just one entry, so we are going to add a new entry which will be Goku and Chichi. Okay, so we have added this. Let's go into our secondary node of the first cluster. We have made a partition, rs.slave. Okay, so use movies db.mm.find. Yeah, data is over here. Now let's check in the other part of the cluster. So what do we have over here? Okay, rs dot slave. Okay, this itself shouldn't work, but then it's okay. Use movies. Okay, db.mm.find. Yep, as you can see, data has not been replicated over here in the fourth and the fifth node. Similarly for the fifth node, let's just quickly check it. Okay, use movies db.mm.find. Yeah, so data has not been replicated, as you can see. Now what we are going to do is I'll quickly log out of these mongos and I'll be back again. Okay, so what I did was I just logged out of the mongos. Now this is the node 4. Let's just quickly put these commands. What these commands are going to do, as you can see, it will drop the rule from the input chain of the IP tables. So node 4 will now listen traffic from this node as well as from this node. Let's do the same for 5. Okay, so what is happening now is, if you want, I can show you the IP tables, that everything is clear now. Yeah, everything is clear. Let's just see whether this node itself is a primary right now or not. So what I've done is, yeah, so let's check the status quickly. Okay, as you can see, now node 5 is secondary, so is node 4, node 3, node 2 is secondary, and node 1 remains primary. So the data which we added, let's check that data in node 4, which was outside our cluster. Okay, now the new data should be present in our node 4. Yeah, so you can see that the new data is now over here. Previously it wasn't present. See this? Iron Man mispatch. Now the new data Goku Chichi, it's present over there. That means we broke the cluster. New data did not get reflected in the outside nodes which were outside the cluster. Once the cluster was joined, the new data was reflected. So I'm going to set up my Riak and I'll be back. Okay, so this is the recording for the Riak part. Please make a note of the Riak name and the IP addresses. These Riak nodes are in the private subnets of a VPC. So I do have a jump box as well to log into these. So the jump box IP address, this is the jump box. So I'm inside the jump box right now. I'll log into one of the instances. Okay, so similarly I'll log into other instances. Till then I'll pause the video. Okay, so currently I've logged into all the 5 instances. This is the status of the cluster right now. All are up and running. Let us see the Riak security groups as well. So all the Riak nodes are in the Riak SG security group, which has an outbound traffic. All see, this is the inbound traffic. All these nodes are the inbound traffic. This is the outbound traffic. So now I'm gonna add add some data in my Riak. Riak is a peer-to-peer architecture. So I've added the data in the first node. So you can see my data 1. Now we'll try to access the same data from the other nodes. So this should be replicated in the other nodes. So as you can see, it's replicated in node 2. This is replicated in node 3. For the node 4 as well, it is replicated. If you want, we can change the IP address to check it. So similarly in node 5 also. Yeah, This has been replicated. Now in order to make a partition, I'll be using IP tables. So I'll be running these two IP table rules in node 3, node 4 and node 5. So what the above two these two rules will block the traffic from node 1 and 2. These three will block the traffic from 3, 4 and 5 on 1 and 2. Okay, so now the cluster has been partitioned. Now let me add some data, my data 2, for the same key. Let us add it over here. Okay, so data has been updated to my data 2. Now what we'll do is we'll try to access this data on the other side of the partition. Let's access this over here. Let's try this. Okay, let's try over here. Yeah, so the status has been updated for the React, which shows node 3, 4 and 5 are down. Okay, request has been timed out. Yeah, so okay, now we checked, we had updated the data to my data 2, but you can see that it is still my data 1 in the other part of the cluster. So now what we are going to do is we are going to clean the IP tables so that the cluster will be formed once again. So I'll be running these three rules on node 1 and 2. Let us quickly check the status of the cluster. Yeah, so the cluster is up and running. Now what we can do is now the new updated data, which is my data 2, this should be reflected on the other part of the partition. Okay, this will take some time to update, but this shows the other part of the cluster had shown my data 1, which shows that React is an AP system where it makes sure that the data is always available, but it does not guarantee that the data will be updated. Yeah, so as you can see, the data got updated now. So in AP, uh, AP system makes sure of the availability. That's why it compromises on the consistency. That's why you saw the delay right now. That was due to consistency. So here we saw that the React cluster forms a ring of data and is an AP system. Thank you.